Okay. All right, we're up. We are up and running. Thank you all for joining us. We're going to get started here in just a few minutes. Good. Real loud. Can you hear me? Chris, you give me a sound check?
All right, can you hear me okay?
We got me, we got Chris. There's a little bit of a lag. Thank you for joining us, everybody. We're just doing a little quick sound check here. We'll get started here in just a few minutes.
And thank you for the chat online, confirming the sound check.
Awesomeness. Thank you all so much. We're going to get started here in just a few minutes. Got about 3 minutes left here. Let some people join us. Thank you all so much for joining us. We greatly, greatly appreciate it. And we'll get started here in just a second. All right, thank you all for joining us. We're going to get started here in just a second. Just doing a sound check. I got my man Sean McConnell here, Asheville Insight Partners, HVAC rep extraordinaire. If you need anything in Asheville, give him a holler. He's our sound check guy. You're going to hear me asking him some questions here in the background. So we're going to get started here in just a few minutes. Thank you all for joining us. So we've got some people coming in, and thank you so much. Any questions, please throw them in the comment section. We will shut the music off here in a minute when the timer runs down, and we will get started. We're super excited to be doing this today. We are streaming live on YouTube and LinkedIn at the same time, which appears to be going pretty well at the moment. So we're pretty excited about that. I think we got a confirmation on the visual and the audio on both platforms. So thank you all so much for joining us. We're going to get started here in just a little over a minute, and we'll get this thing kicked off. Tony Mormino, Insight Partners. Got Chris Adams here joining us, Sean McConnell in the background here, helping with the technical aspects of this presentation. So we appreciate everybody who's joining us. We're going to get started here in just a minute. Hey, Eric, how are you? Got Cliff, Eric, Sean, Chris on the chat. We got 59 watching so far. Thank you all so much for joining us. We are going to get started here in just a minute. So okay, we're getting down to the wire here. We're going to get started here in just a minute. Thank you all so much for joining us. We appreciate it. 15 seconds here. We're going to kick this thing off. So thank you all so much. Yeah, it's just a lag. All right, that ends the countdown. So okay, thank you all for joining us. My name is Tony Mormino with Insight Partners, and we appreciate you taking the time to join our presentation today. Today's presentation, we're going to be talking about how to read a psychrometric chart. It's a very basic introductory course to psychrometrics. A lot of people are overwhelmed by the chart, but we're going to break it down into individual components. So I'd like to offer you a virtual handshake welcome. And thank you again for taking your time. I know we all get inundated with requests to join these online webinars and events. And so we greatly, greatly appreciate you joining us today and taking the time to choose us as one of your options. And hopefully we're bringing you something here that's going to be helpful for you. So thank you very, very much. We do appreciate it. So a little bit about our company before we get started. I work for Insight Partners. We are an HVAC rep firm, primarily in the Southeast. We rep products such as Aon, Samsung, Armstrong, Bosch, CDI, and Miller Lehman across the territories, plus many, many other products. All of our products and company information can be found at insightUSA.com. You can go there and see what products we rep in your region and your contact information and all that information there. So just a second here. Okay, so moving along. Excuse. Okay, testing.
Gotcha, Tony.
Okay, sorry about that. Lost my mic for a second. Okay, this is what happens when you do this stuff live. So we are primarily located in the Southeast. We have offices in North Carolina, South Carolina, Georgia, and most of Florida. So come check us out if you're in one of those areas. In addition to HVAC new equipment sales, we have a full parts department across the region and a full controls and service division. So come and check those out if you're in the area. So one of our core values is working together, we're stronger. And I've highlighted a little area of this core value, which says our true strength comes from a tireless passion to serve those around us. And we truly, truly believe that internally and externally, which is why we do these webinars. So to that end, we started a YouTube channel called Insight Partners HVAC TV. And our tagline is educating the HVAC community. So we love to share what we know to help educate those in the industry. And again, today we are live streaming on LinkedIn and YouTube at the same time. We've not done this before, so we hope everybody can hear us and see us okay. We greatly appreciate it. It's pretty exciting for us. We're reaching a lot of people today, so it's super, super exciting. Okay, so that's a little bit about our company. Now, a little bit about me and my co-host here today. So my name is Tony Mormino. My official title here is Technical Sales and Marketing Director for Insight Partners. I started in the industry in '97, graduating from the University of Florida with an engineering degree. Went to work for Trane. I was lucky. The first couple months of Trane was all psychrometrics, so it laid a good foundation to my experience as an HVAC sales engineer. I worked there for 10 years. Then I went on to work at a private rep firm with two business partners. I was part owner, manager, and sales engineer in Jacksonville, Florida for about 10 years. And now, in my 25th year, I am with Insight Partners. In my new role as a marketing director, one of the things I get to do is these webinars, which are really super exciting and a lot of fun. And I'm lucky to have, and I am in Asheville, North Carolina, is where I'm located right now, where I'm streaming from. And I have Chris Adams, PE. He is our VP of Engineering for Insight Partners. I'm lucky to have him here with me today. He is in Charlotte, North Carolina. And Chris, would you introduce yourself and tell us a little bit about yourself?
Good morning, everyone. Yeah, Chris Adams here, actually just north of Charlotte as we're going through. Been with Insight Partners since we came together with it, because we actually have some roots back into the 50s with the HVAC rep business. So graduated from North Carolina State University, went into industrial with steam turbines, gas turbines, then came into the HVAC industry in about 2004, and kind of the rest is history. So we're here to support the team. I cover all of Insight Partners plus some other territories for the folks. So thank you for joining us, and we'll get this thing going.
All right. Thank you, Chris. We appreciate it. Chris is a very valuable resource and knows a lot of stuff. So it's good to have him here. Okay, so PDH credits. If you are in North Carolina, South Carolina, Georgia, or Florida, we can give you PDH credits for this webinar. tmormino@insightUSA.com is my email address. Email me directly, or your account executive, if you have that handy. We're going to put this email address in the chat. It is also in the video description on both platforms. So hook up with me if you want to get your PDH credits. Please feel free to ask questions in the comments section. We will probably answer them at the end. If it's a short answer question and it's applicable to the slide we're on, maybe we'll hit it there real quick. It just depends on the time and how it's going and how many questions we actually get. But please ask them. We will be glad to stay around as long as we need to answer any questions we can. So I'm going to go ahead and get started with the actual presentation. Before I do that, I'm going to clean up the view here a little bit on the screen because we're going to make this a little more user-friendly so you can see all the stuff on here. Okay, so how to read the psychrometric chart. Again, this is a very basic introductory course. We're going to break this down. I know the chart can look a little intimidating at the beginning, but we're going to break this down in its individual components. So the word that comes to most people's mind when I say we're going to do psychrometrics is this: boring. Okay, so in the words of Homer Simpson, Chris, I think we're breaking new ground. I don't think Homer's ever been in a psychrometric presentation before. This could be an absolute first in the industry. So boring, and why do I need to know this? I don't understand. I can just tell you from my personal experience, having a grounded, having the fundamental knowledge of psychrometrics in the HVAC industry has been extremely, extremely helpful for me. It's a very valuable tool for getting the jobs right the first time, selecting the equipment, sizing them, et cetera. And it's a very valuable tool if there's a problem that arises and you can't figure out. Psychrometrics could help you in that way as well. Whether you're in sales, service, an engineer, or contractor, it's a very, very valuable tool. So hopefully you will get something out of this. So a little bit of history. Willis Carrier, maybe you've heard of him, started a little company called Carrier. And in 1911, he is credited for coming up with the psychrometric chart. And psychrometry, just so you know, is the science of air properties and processes of heating, cooling, dehumidification. Humidification is also the cornerstone to the science of HVAC engineering. So extremely important in the business that we are in. So a little bit of history. The word breaks down as, I believe it's suchron, meaning cold, metron, means of measurement. So psychrometry, psychrometrics comes from those two Greek words, which I think is pretty interesting. Psychrometrics is not confined to the world of air conditioning. It is used in the fields of agricultural and aeronautical engineering, food engineering, drying of crops, grains, and pharmaceuticals, dehydration, meteorology, and weather reporting. So used in various applications and disciplines around the world. So here's the agenda for today. I've got 5 short sections, and then I've asked Chris to do a quick couple slides on a very appropriate application to what we're going to learn today. So the first thing we're going to talk about, and basically you can't get the psych chart unless you understand the properties of air. So we're going to quickly go through the difference between dry bulb, wet bulb, dew point, relative humidity, and humidity, which are 2 different things, okay? First, we're going to start with dry bulb temperature. Very simple. If you have a thermometer or something on your porch that reads the temperature, that is the dry bulb temperature. In this dry bulb, in this thermometer here, it looks like it's about 103 degrees, very hot. So if it's 75 degrees in your office, that's typically referring to the dry bulb temperature. Pretty simple. Everybody understands that one, I'm sure. So the best way to describe wet bulb, I think, is to look at this tool called a sling psychrometer. And if you've been around a while, you've seen one of these. And basically what you do is you grab this wood handle and you swing this thing around above your head as not to smack yourself in the face with it. And it reads a couple different things. So this is a dry bulb thermometer, which is just a regular thermometer reading the temperature of the air. You have another thermometer on here, which has a wet sock or a wet wick at the end of the thermometer. So what happens when you're reading the wet bulb temperature, it takes in effect the evaporation and cooling effect of the air. So if the air is dry, the water from this wick will evaporate, thus cooling this thermometer. So it will be cooler than the dry bulb. So if the dry bulb is 70, this might be 65, something like that. So that's how wet bulb works. I think this is a good way to show the difference between the two. So what happens is the drier the air, the more evaporation from the wick, the greater the cooling and the lower the wet bulb temperature. So it'll always be lower than the dry bulb. Okay, the next air property we're going to talk about is dew point. So dew point measures when the moisture will drop out of suspension. So if you look at this picture here, you have a cold bottle of water. Maybe it's 40 degrees out of the fridge. You walk out of the porch. If the dew point of the air outside is greater than 40, then you will get condensation. So you'll get what you see here. So where is this applicable in our business? Well, let's say you have a cooling coil that's 45 degrees. If the air blowing over the cooling coil has a dew point greater than 45 degrees, then you will condense water out of the air, which is a good thing if you're trying to dehumidify the space. So dew point is very important. Okay, relative humidity. This is a good one. So RH is the percent of moisture in the air versus how much it could actually hold. It is relative to the temperature. So let's demonstrate this by putting up a few containers here. We have our first container of air. Let's say the dry bulb is 55 degrees. Let's say we heat that dry bulb up to 75 degrees. We would expect that the container would expand. And let's heat it up again to 95 degrees. So we have 3 different volumes of air here at different dry bulb temperatures. So what does 50% RH look like? Well, if you filled these containers halfway with water, that is what 50% RH would look like, okay? One thing to note is, although they all have the same percent RH, they are vastly different in quantities of water. And we're going to talk about that a little bit later when we compare this to dew point and which one works better for controlling humidity, monitoring for controlling humidity in the space. So more on that to follow. So humidity, which is different than relative humidity, is the actual amount of moisture in the air measured in grains. It's grains per pounds of air, but we're just going to call it grains. So if you took a pound of air and wrung it out, all the water that came out, if you put it in a bucket and weighed it, that would be the grains of moisture in there. So it's the physical amount of water in the air. It is not relative. Chris and I were putting this together, and we've been doing this a while. We're like, what the heck is a grain anyway? Where did that come from? So just a little bit of a factoid here for you. So one of the earliest units of common measure in the smallets, it is a uniform unit in the Troy system. So I don't know a lot about the Troy system except that it's old. It's been around a while. The ancient grain was defined as the weight of a designated number of dry wheat kernels taken from the middle of the ear. It was also used as the original basis for the medieval inch, which was defined for instructional purposes as the length of 3 medium-sized grains. That has nothing to do with this presentation. I just thought that was pretty neat. So thank you, Britannica.com, for this information. For your knowledge, to wrap your brains around it, 100 grains is about equal to 0.23 ounces, which is about the weight of a quarter. And 100 grains is pretty close to a typical design day in most areas. So that's what we're dealing with usually is a 0.23 ounces per pound of dry air. Okay, the next is enthalpy. So I'm going to spend the next 45 minutes going through all of these equations. No, I'm just kidding. So I was Googling enthalpy and I was looking for a picture that would show what enthalpy was. I certainly am not going to go through all of this here. But for the purposes of this prezo, let's say enthalpy is the total energy in 1 pound of air in BTUs. So it includes what we call sensible heat and latent heat. And that is more discussed in part 2 of this presentation, which you will get an invitation to after this part 1 basic introduction. So just think of it for now as the total energy of the air. Okay, so now that we have a better understanding of the properties of air, let's go ahead and build the chart. So when you look at this chart, first off, if you're not familiar with it, it could be very intimidating. There's a lot of data here. There's a lot of lines. There's a lot of detail. It's very confusing. But we're going to break it down and build one line at a time with the 5 most common properties of air, which we just reviewed. So some of the stuff we won't look at for this presentation. So what we did is we actually took this and we kind of digitized it into a very simple version for purposes of this presentation. Okay, so this would be the outline of the psychrometric chart. So if you're going to build a chart, you need data. And we refer to this as the X or horizontal axis, and this is the Y or vertical axis. And you need 2 points, and you plot them, and you draw some lines, and there you go. You start building a chart. So dry bulb is the easiest of the two. In our chart at Insight Partners, it ranges from -10 to 130. All charts are a little bit different in increments of 1 degree. So we can go ahead and plot that on the X or horizontal axis. They are uniform, and they are almost straight, vertical, up and down. We'll talk about that more in a minute. And I'm just drawing in a few at a larger scale here so we get the sense of the motion. So 110 degrees along this line, anything along this line would be 110 degrees dry bulb, 90-degree dry bulb up and down this line, etc., so on and so forth. For a wet bulb, let's say you took your sling psychrometer outside and you put a little water on it and you swung it around and maybe you read this data point here of 52 dry and 50 wet. And then you read another data point of 70 wet bulb and maybe 90 dry bulb. So you start putting these points on here, and then maybe you start looking at some kind of a sequence here, and you start drawing some lines, and you'll notice the wet bulb lines go like this. So this is basically how the chart's built with all the data points. So the wet bulb lines run along, the numbers run along what we call the saturation line here. 80 degrees, anything on this line would be 80 degrees, et cetera. Anything down here would be 70. So that's how the wet bulb lines go on the chart. Next, we're going to add the dew point lines in the same fashion. Let's say we took some data, we threw it on here. Anything along these horizontal lines would be the dew point. You will notice they are not uniform. They are very close down here and spread out up here. That's how the dew point lines go on the chart. Next, we're going to add the relative humidity lines, which are basically slopes, 20%, 30%, 50 shown here, all the way up to 100% in this direction here. So that's how the RH lines go on the chart. Next, we're going to look at grains, which run in the same manner as the dew point. They're just at a different value, different scale. They are uniform, down from 0 up to approximately 200 on the chart, and they run horizontally like this. So anything along this line would be 20 grains, 60 grains, 100 grains, etc. So you can see the chart's kind of starting to come together. Enthalpy, which is the total energy in the air, these lines run across like this. Okay, so anything along this line would be enthalpy of 20 BTUs, etc. Now, let's go ahead and put all these together. We'll overlay them, and you can see how the chart kind of starts to take form. So dry bulb temperature, vertical lines, mostly. Wet bulb temperature has a slant. Dew point temperature is horizontal. We'll go ahead and add the RH lines, and now you can see the chart starting to take shape. We'll go ahead and add the grains, put it as a different color so we can see it. Gets pretty busy pretty quick, then the enthalpy right here. So we start to see the chart come together, and let's go back to the chart, and we're going to go ahead and see. Now you can see how all this stuff comes together to form this. Obviously, this is in tighter increments than what we were just showing. Let's see here. So what we're going to do is we're going to add some stuff here. I'm going to make this screen a little bigger. Hopefully you can see that pretty well on your screen. So we're going to go ahead and plot a few different things. So let's go ahead and look at 95 degrees, 70-degree dry bulb. So if we go down here, this is our dry bulb here, and we pick 95 degrees, and we pick 70 degrees, and we follow these lines. Now, I did this illustration to point out something. You'll notice I drew a straight line here, which doesn't line up with the dry bulb line. The dry bulb lines are actually not perfectly straight up and down. So not very important, but something to note for the future. So if I was to draw this on the chart, I would draw it a little bit more slanted. I just wanted to illustrate that. So how does it look if we wanted to draw 70-degree wet bulb? So here's 70-degree wet bulb. We draw this line here. So this is a wet bulb line here. Anything along this line would be 70 degrees. If we did it for 55-degree wet bulb, anything along this line would be 55 degrees. And the dew point of 60, for example purposes, would be right here. And I'm just kind of drawing some stuff in to show you how the chart's built. We'll highlight that a little bit here so you can see that. Gives you kind of an idea of how the lines actually lay on the chart. If we looked at the relative humidity lines, you know what? I'm going to back up and zoom in here. These are the relative humidity curves. They go from 0 up to 100%. The smaller ones are to the right here. You can't quite see them. They are right here. We rarely get down to that point. But if we were to draw some relative humidity lines here, you would see something like this. So 50%. So anything along this line is 50% RH. Anything along this line is 20% RH, and so forth. So that's how the humidity lines go on the chart. So enthalpy, so if you'll notice on this chart, we have a little, these lines here that run outside of the chart. These are enthalpy lines. What we do is we line up the numbers. Let's say we lined up 20 with a straight edge and we drew it straight through. That would represent the enthalpy line of 20 BTUs. If we did it for 40, that would be the line we would draw for 40 there. So gives you an idea of enthalpy. Okay, so I'm going to go back and shrink the screen here. And next we're going to look at, let's see here. So next we're going to look at, we looked at properties of air. We looked at building the chart. Now let's go ahead and move around the chart. We're going to show you kind of when you move in what direction, what happens. And we're going to look at these psychrometric processes of cooling, heating, humidification, and dehumidification, and of course, the combination of a couple of those. So if you go to the chart, and don't worry about being able to see the actual numbers and everything here in detail, what we're trying to do is get a general flow for what happens when you move in a specific direction in the chart. The first thing we're going to look at is cooling and heating. So for that, we're going to look at dry bulb temperature. And I've just drawn the lines here and highlighted a couple temperatures so you could see 20 degrees down here is relatively cold, 120 is hot. And if we move from right to left on the chart, that would be the process of cooling. So we went from, let's say, 118 degrees down to about 60 degrees. So that's a cooling process on the chart. So anything moving in this direction, we're cooling. And conversely, anything moving from left to right is heating. So we moved from about 72 over to 125. That would be a heating process. Humidification, adding humidity. Dehumidification, removing humidity. We'll look at dew point for that, which is a great indicator of the humidity levels. So I've drawn in some lines here. This would represent 40 dew point, which is relatively dry, and 85, which is pretty saturated, high dew point air. If we go up on the chart, from bottom to top, we are adding humidity, increasing in humidity if we're moving in that direction. And conversely, if we're moving down the chart, we are removing humidity in this way. And you could see we're probably going from about, 73 dew point down to 15 here. So obviously that would be a dehumidification process. Altogether, just as a summary, cooling, heating, humidification, dehumidification. And I would like to point out that rarely are we moving in a straight up and down or left to a right to left situation. The only straight line we could really do on the psych chart is the heating line. And we'll look at a combination of a couple of these here in a second. All right, so what does cooling and dehumidification look like? So we talked about cooling, talked about dehumidification. So this would, moving in this general direction would represent we're removing heat and removing moisture from the air. So very common, direction on the psychrometric chart for a air conditioning application. We're moving somewhere in this general area down to somewhere in this general area where we're cooling and dehumidifying should everything be working correctly. So heating and humidification, we talked about heating, moving from left to right. Adding humidity is going up. And the combination of the two is heating, and humidification is in this general direction, okay? So I hope that gives you a general feel for the directions on the psych chart. It's very helpful, in our industry, especially for me when I was a sales guy, is to, when an engineer calls me with an application and, he's trying to get, let's say from here, and I'm using my highlighter tool here, hopefully you can see it, down to here, I could pull out the psych chart and kind of talk through what products, what technology, I should say, not products, would be the right fit for this application. So maybe I would take this and run it through a chilled water or DX coil down to here and get to this point. And then maybe I would take this and run it through a desiccant, actidescent type product, which is a removal of humidity and heating. I would take it to here and then I would post cool it with a chill water coil or a DX coil. And this is a little more advanced, but I wanted to show you an example of how we use these just on the fly. And in the next presentation, part 2, we go through a little more of these in in detail. So, okay, so moving right along, we've done the properties of air. We've built the chart. We moved around the chart. Now let's use the chart as a common tool of determining air properties. This is a real useful tool. A lot of this stuff too we're showing is done, on apps on your phone and on your computer. But it's nice to know you can plot these on a chart and get the actual data really quick by hand too. So if you know 2 of the air properties, you can find them all. And I'm going to use this handheld tool that I took a picture of 2 days ago at my house, which was just a beautiful 78-ish degrees and 28% RH, which is a good, nice mountain day. Okay, let's take that data and let's calculate on the psych chart the wet bulb, the enthalpy, and the dew point. We're going to look at that here. Okay, so I'm going to make this screen a little bigger so you can see it a little better. There you go. Hopefully you can see that okay. All right, so if we plot what we know 2 points. We know 75 degrees. I'm sorry, it was 78 degrees, which is right here. So if I look at my dry bulb temperature of 78 degrees, I can go ahead and draw that line in. We saw that it was 27% RH, which is represented by this line right here. And now we could just draw a point and we can shoot off of this and find all the other data on the chart. So if we want the wet bulb, we would draw this line here and go up to this part of the chart here, which looks like 55, 56, 57 and a half. Looks like it lands on that very nicely. And now we know our wet bulb temperature. If we wanted our dew point or our grains, we would draw this line to the right and we get to right here, which we can point out as 41 degree dew point. So now we have our dew point, which is a beautiful, beautiful day, that's for sure. If we wanted our enthalpy, we would draw this across. And what we would do is line up these 2 values with our straight edge such that they go through this point, and that gives us the enthalpy in this case of 24.7. And I'll kind of zoom in on that to see 1, 2, 3, 4.7. Okay, so that looks good. Okay, so that's an easy way to get all the points from 2 points, all the properties of air from just 2 points. So example number 2, this is a good one. So when I was in Florida, a typical design day was 95, 78. So let's look at that on the psychrometric chart and calculate the dew point, grains, and relative humidity from that. And I'm going to show you a little bit something about relative humidity, which is fairly important. Okay, we know 95 degrees and we know 78 degree wet bulb. So we're going to go ahead and plot those 2, the intersection of which is our point. And now that we have this point, we can find all of the properties of air from this one point. So we can see that the dew point is 72 by drawing a straight line over to the dew point. The grains, which are located by the dew point, I'll zoom in here. The 120 is kind of covered up, but you can see 110, 130 grains, so 120 grains, which is what I call a very grainy day, a very hot and humid day in Florida. Now, one thing, here's what I wanted to point out that's very interesting. So the relative humidity is 47%. Okay. So the relative humidity is what we would consider pretty low, but it's a very hot and humid day. So that's kind of one of the things to be careful with relative humidity. It's not a real good indicator of the amount of moisture in the air when you're trying to control dehumidification equipment or trying to monitor and see exactly where you are on the psychrometric chart. It's really difficult to use relative humidity, which is why we typically use dew point. Okay, I'm going to make this screen a little smaller again, come back on here. Okay, so we talked about the properties of air, and thank you all so much for joining us. We're getting here close to the end. Chris is going to have some at the end here for us too, and we'll talk about the next step in the psychometric series. So we've done all these, moved around the chart, determined the properties of air. Now we're going to talk about one of my favorite topics, relative humidity versus dew point, and why it's important to know the difference between the two. And this is very commonly misunderstood in our industry. So this is a good one to go over a little bit in detail. So which is better to track humidity? Relative humidity or dew point? Well, let's look at the two. So the relative humidity, The value is relative to the dry bulb temperature, as we discussed before in our example with the containers. The dew point increases in value as moisture in the air increases. So maybe that's a better one to look at. Let's take a look. So if you remember, RH is the percent of moisture in the air versus how much it can hold. It's relative to the temperature. So if we have this container like we had before at 55 degrees, we heat it up to 75, and we go to 95. We have 3 containers, different volumes. What does 50% RH look like? Well, we went through this before. And I'll go ahead and number these. So here's what's important to note. They all have the relative humidity value of 50, but they're vastly different in the amount of moisture in the containers. Okay, so that's super, super important when we're looking at, especially when we're looking at dehumidification sequences and controlling tight tolerances and spaces and things like that. So let's use a psychrometric chart to show this graphically. So if you plot the relative humidity line of 50%, which I just did here, and you take our 3 dry bulb positions of 55 degrees, 75 degrees, and 95 degrees, you went ahead and numbered these. So these numbers here equate to the numbers here. So they represent where we are in these 3 buckets of air. So if we then took the dew point for these points, let's see what these values show us. So 37 degree dew point down here, 55 in the middle, and 74 up top. So you'll notice that the dew point is a much better indicator of the amount of moisture in the air because it tracks with the moisture. So 74 dew point is very high, 37 is pretty low in common applications. And that is why it's better to use the dew point, especially as a control point for dehumidification equipment, or when you're looking at a space and you're trying to control tight tolerances. Dew point is a way better way to do that. So why do we look at relative humidity? Well, it's very inexpensive to actually measure the relative humidity. Dew point sensors are a little pricey. So what we do in reality in the field is we measure the relative humidity. Let me put this up here. And we know the dry bulb and we convert that into dew point in the program using psychrometrics. So that's how we typically do the dew point and why we do it that way. So in summary, we looked at the properties of air. We built the chart. We moved around the chart. We determined air properties, and we talked about relative humidity versus dew point. So is that all there is to psychrometrics? Is that all I need to know? No. So we have a psychrometrics part 2 presentation called Beyond the Basics, where we talk about air mixing, sensible heat ratios. We do a little constant volume psychrometrics, full and part load analysis. And this is the next one in the series. And we will send out a link to those who are registered, and we'll put a link here in the comments while Chris is going through a few things here in a minute. We hope you will join us for that. And we also do small group training. So if you have a need at your company for us to either come in online or come in person, let us know. Drop me a line, an email at tmormino@insightUSA.com, and we'll be glad to set that up if you want some private training for you and your firm. And I'll include, of course, your account executive in that, and that would be a lot of fun. PDH credits, don't forget to email me direct. And Chris is going to show us a very practical application to using the psychrometric chart, something we deal with all the time in makeup air units, I believe. So Chris, do you want to go ahead and do that?
Yep. Okay, so everybody has the capability to see what's going on there. One of the things that I get asked all the time, and this is kind of where this becomes applicable, is what conditions should I use when looking at air conditioning or dehumidification? And always in the engineering world, it depends. And so I just kind of pulled up a chart here and says, all right, let's look at Charlotte, North Carolina. And we have summer air conditioning, 94, 74. We have dehumidification at 82 degrees at 130 grains. So the question is, what should you use and why? So if you're looking at a high percentage outside air that you're bringing in, what I will say, and I'll start with, is dehumidification will cover the air conditioning dry bulb. So let's look at actually what that means and how that works. So dehumidification, the problem with the dehumidification condition is I get to hear this question mainly by owners, but it says, but it gets hotter than 82 degrees. So yes, we absolutely know it gets hotter than 82 degrees, but it basically, if they give you that question, what you're now starting to know is right away, psychrometrics are not fully understood. And we really got to talk about that latent heat, that moisture removal. And so I go in, pull up the back of the chart. So this is kind of exactly the practical application of this. And we've plotted two different points. We've plotted that 94.74, which I've put on there as AC. We put dehumidification condition, which is 82.75.8. And we look at what those conditions are. Well, obviously we know we have 2 points, therefore we can define the rest. Well, from the chart, now I'm going to kind of use that a little bit funny. It says, all right, so it's 39.3% RH. Grains are 94.6, enthalpy 37. So really, is that from the chart? No, I actually have a psychrometric calculator. So you use your phone, use a psychrometric calculator, and you can get these things really precise and understand what's going on. But one thing to note there is you look at that enthalpy, 37.46 in an air conditioning condition, so hot and normal condition, but it's relative 39.3 versus that dehumidification. It's not as hot, but it's a lot more humidity in the air at 75.6% RH. So we're looking at the difference between 65.5 degree dew point up to 73 degree dew point. So here is when you start really coming together with what's going on. There is more energy, aka enthalpy, in that dehumidification design condition. So that's really what we're looking at of what we're trying to go on through here. So we're looking at that energy in the air. So the other thing to look at is let's truly add a cooling process. So we're going to take that 94.74 and cool it off, or we're going to take that 82.75 and cool it off, run it through a cooling coil, and we're going to come out at 55 degrees at 94% relative humidity. Now, yes, we're going to hit the saturation line, but when you think about a lot of it, can you truly be 100% humidity off the end of that coil? And the answer that some would argue is no. So I just kind of use a 94% relative humidity. So if we start at either point, the energy required from the air conditioning point is 66,000 BTU removal, where dehumidification from 82 down is now 75,000 BTU removal if we're looking at 1,000 CFM. So not a whole lot of CFM, but you think about the difference there, that is a tremendous amount of energy, about 3/4 of a ton of air conditioning capacity. So how do we avoid, but it gets hotter than 82? Well, the way I do it is I then go back to kind of where we were and look at it and say, let's start plotting some extra points. Well, obviously, the close to vertical lines are the dry bulb temperature. So I've crossed those points, and so we have that 94 and that 82. We then look at the moisture content in the air and say, all right, how many grains do we have? Well, a real simple way that I come at with is, what is the average moisture content between the two? And if you notice where that ends up, I have a hybrid condition where I use that 94, and then I get the average of the grains for 109.9, and I come up with a new resultant wet bulb, 76.5. You saw when Tony was talking about Jacksonville, 95.78. Same type concept here as we're looking at now, 94.77 thereabouts, and we can really come up with an enthalpy question. And now if you look at what's the total energy in the hybrid condition, well, it was 66.8 to 75.1, the dehumidification condition. Well, this hybrid condition means we do have it covered. We have the energy required if we're looking at high volume outside air to make sure we truly are removing the moisture necessary, and we have a unit that's sized properly in a latent application. So that's really what that's about, just kind of a real practical application of what's going on to say, it's kind of one of those tricks from an engineering standpoint of how do I communicate with my owners and come up with a condition that I know can truly hold my space at my design condition. With that, I'm going to turn it back over to Tony.
Awesome. Thank you, Chris. Okay, just finagling this here for a minute. Okay, we're back. So anyway, we hope that you enjoyed this. Thank you so much. If you would please, if you enjoyed this presentation, please like this presentation on LinkedIn or on YouTube. We greatly appreciate your support there. And please join us. I just posted the links to our LinkedIn page. And if you're on YouTube, please subscribe to our channel. If you like this and want to see upcoming content, we greatly, greatly appreciate it. So here is also a way to connect with us very simply by putting your phone up to the screen and zapping this here. So that concludes our presentation. Don't forget to please, we're going to stick around if anybody has any questions, but don't forget to email me or your account executive for your PDH credit. And please look out for I did post the link to the next part 2, which is going to be Thursday at noon. Go ahead and click on that, register for that. I will also send out an email to anybody who registered for this event. So that concludes the part. We're going to stick around if anybody has any questions. I don't know if we have any questions in the comments. I haven't been checking them. Chris, do you see anything?
I haven't seen any come through specifically, but just a lot of thank yous. So thank you for joining us. If you do have any, we can answer those, however.
Yeah, we'll stick around for a few minutes here. Thank you all so much for joining us. Please like and share if you want this video. Please like us on LinkedIn. Please connect with us on LinkedIn. We are trying hard to get events out that are have a nice user experience and also have a nice quality content that you can use throughout the day. And this is a good fundamental one that builds upon part 2, 3, and 4. And every time we do one, we get a little more detailed in the processes of psychrometrics, down to complex things like desiccant wheels, makeup area units, enthalpy wheels, things like that. And I know for me, understanding the psychrometrics has really helped in understanding a lot of the processes and a lot of how the applications and providing the right application and product for the right scenario is extremely important, obviously, in this industry. And okay, Chris and I have been doing this a while.
Questions here. Eric represented, say, Tony, no PDH for us in Pennsylvania. Well, the answer is, as a PE, we are responsible to report what we feel is a PDH credit. So what we are licensed for, so we've actually worked with the states that we are located in, North Carolina, South Carolina, Georgia, and Florida, where we have truly registered with them to offer PDH training courses. Now, as an engineer, you can actually claim this course as well if you attended it, if your state allows you to do that. So we will send you a certificate, Eric, or anybody in the various states. But again, the only ones that we can truly, where we have registered, are the 4 down in the Southeast. So yeah, you can send that over to us. And we can definitely get you a certificate, and you can use that as your wish, because obviously PEs, we have to self-report about what's going on. Travis says, do you ever use the evaporation condition versus dehumidification for outside air unit design? That's exactly what that dehumidification condition is that I'm looking at. That's kind of that evaporative side of it. So yeah, that's exactly where I'm looking at, that 8276. So it's kind of, I call it dehumidification. So we can call that the evaporative side. But again, I avoid that. I've had the question, and I'm going to pick on engineers themselves. Engineers themselves have asked me, but it gets hotter than 82 in Charlotte. Yes, I know. And so that's where I've just kind of avoided that question. So owners, we see it a lot. Engineers, I see it every once in a while. So we'll have a little fun with that. Eric, the software I'm using to calculate mine is actually ASHRAE. I actually have it's a very old version, so it's not quite up to date. But when I'm looking at that software for psychrometric state points, it is in the ASHRAE Fundamentals program that I got back in 1997. So it's been out there for a long time. But most of the ones that you can do now it's an app on your phone, and they're free apps from a lot of different companies. So you can pull up that software. My computer one, the other one you can actually do is you can put it in Excel. Interestingly enough, there are some programs out there within Excel now that are freeware that have you put in state points, and you can pull those up as well if you're just putting that in from a psychrometric calculator standpoint. So there are some of those people that have built those. So I've actually got some that I've built myself as well with what I've found online. So Google is always going to be your best friend. I think that was the question.
Thank you, Chris.
Coming through, Tony.
Great. Okay, well, thank you all so much again for joining us. We really appreciate it. We know your time is important, and you have a lot to choose from today for watching these things. So we hope you found this informative. Please like this video on LinkedIn and YouTube, we would greatly, greatly appreciate it. Please subscribe to our YouTube channel and our LinkedIn page. All that information's in the comments. And we'll see you at the next one. I put the part 2 link in the description. If you registered for this event, look out for an email. I'll also send that to you as well. So we will go ahead and sign off. Thank you all again so much for joining us. We greatly